Welcome to 12.9, Proving the Pythagorean Theorem. Here are our topics, key skills, and understandings. This is a grade 8 topic. So we're going to apply the moving and additivity principles to prove the Pythagorean theorem. Now, we're going to use the same ideas that students use to find the areas and explain area formulas, and we're just going to apply it to this theorem. Now, this is really important. It's named for the Greek mathematician Pythagoras, who was around in 500 BC. But there's a lot of evidence that this theorem was known long before this Greek mathematician, possibly as far back as the ancient Babylonians around 2000 BC. So even though it is named the Pythagorean theorem, we do need to acknowledge that it was around and used much earlier. In this section, we're going to have a lot of exploration, so please take the time to do it. Get all the supplies. It's valuable to make sense of the Pythagorean theorem. Start here and then press play when you've completed this entire exploration. So we are talking about right triangles, and it's really important. We're not talking about all triangles. The Pythagorean theorem is only about right triangles. And what it says is that the square of the length of the hypotenuse is equal to the sum of the squares of the legs of the other two sides. So basically, if C is the length of the hypotenuse and A and B are the other two sides, then this is true. And when we look at a triangle, the hypotenuse is always across from the right angle. Okay? Now you can pick your A and B. Those don't matter, the sides, but the hypotenuse is always across from the right angle. And it's just important to make sure that you're using the same unit. So if we're talking about feet, everything's in feet, or everything is in inches if we're talking about that. So looking again here, it doesn't have to be named ABC. So here's ABC. Notice this right angle is between these two sides, which means this side must be the hypotenuse. And here, it doesn't have to be ABC. This is a right angle between these two sides, so they're D and E. And this must be the hypotenuse, so this is F. One way to think about this is leg squared plus leg squared equals hypotenuse squared. It's not so much about the letters A, B, and C. So why is it true? You can plug it in to see if it works for right triangles. And we could continue to check as many as we wanted, but that could get really tedious, and really there's an infinite number of possibilities, so that's why we need a proof. And basically a proof is required to know for sure if a statement is true. And today there are still so many mathematical principles that are still being proved currently today. It's thorough, precise, and logical. And for the Pythagorean theorem, there are hundreds, and you're going to go find your own that are not taught in this lecture video for the discussion board this week. All right, for this exploration, I really encourage you to download and print Activity 7. It's in Canvas and it's off to the side here, but then you can really cut and rearrange these shapes, and I really encourage you to do that. If you're not able to do it, then just do the sketch. It's in your textbook. You can trace it if you have an e-text. Really take the time to do this exploration because we're going to do it without the cutting, but it's so much easier if you make sense of it here. Press play when you complete the exploration. All right, so both figures here are drawn with side length A plus B. They're squares, and again, this is length A plus B. This is B plus A, which is the same. And notice that the first figure is divided into two squares and two rectangles. So here, A by A, but A by A plus B, or A by B. And then on the second figure, G, we have a square in the center, and then we have four right triangles surrounding it. And they want us to call the hypotenuse of each of these C. So I'm going to go ahead and call these C. What is the total area of each figure? So I'm going to actually write it in. So each little piece. So this is A, they want the area. I jumped ahead. Each figure. So this is a square A plus B by A plus B, same thing. So this is A plus B squared. Both areas are A plus B squared. Now they want us to determine all the little pieces and write them in. So this is going to be A by A squared, A by B, A by B, B by B. This is a right triangle, 1/2 base times height. So 1/2 base times height, AB. And it's going to be the same for all of these. and this is a square, c by c, this is c squared. Add up the area of the 4 regions in figure F and set this expression equal to the sum of the areas of the 5 regions in figure G. So I'm going to add up all these. So I get a squared plus ab plus ab plus b squared. They want me to set it equal to adding up all of these. So that would be 1/2 ab plus 1/2 ab plus 1/2, there are 4 of these, plus c squared. Then rewrite this equation using as few terms as possible. So this is a squared plus 2ab, there's 2 of them, and we've got 4 of those. 4 times 4, I have 4 of those. So I'm going to just kind of keep going here. I hope I don't run out of space. 4 of those is 2ab plus c squared. I'm going to subtract 2ab on both sides, and I get a squared plus b squared equals c squared. And so because we already agreed these are each equal to that, this proves the Pythagorean theorem. Go ahead and give these a try. Press play when you're ready to see the solution. And there you go. Let's take a look at let's apply the Pythagorean theorem here. So in a right triangle, find the length of the side not given. So first, don't assume that anything is labeled correctly. But in this case, yes, we do have a hypotenuse over here. So it's going to be a squared plus b squared equals c squared because it's a right triangle. So we get 8 squared plus b squared equals 17 squared. There's lots of different ways to do this, but I'm going to go ahead and just get all of the squares. So 17 squared is it is 289. There we go. A squared plus b squared. There we go. And then we're going to subtract 64 on both sides. So we get b squared equals, and then in my calculator, I'm going to type 289 minus 64, and I get 225. I'm going to square root both sides. You can do this right into your calculator, and you get b is equal to 15, so the unknown side length, and they don't give us units, you could just say units, is 15. This is 8, 17, and this is 15. In this example here, they want us to find the height of the tree shown. So here, we are trying to find this, and we don't know it. So we are going to set this up. Let's call, this is our right angle, this is our hypotenuse. So you can call this C, and we can call this A and B. And we can keep it X, honestly, if you want. So it would be A squared plus B squared equals C squared. Our A is 23 squared. Our B we don't know. Our C is 36 squared. You could totally keep it as B squared. So 23 squared is 529. 36 squared is 1296. We're going to subtract 529 from both sides. We get x squared equals 767. We're going to square root both sides. We get x is approximately, when we type that in, we get 27.69 feet. This is the approximate solution. If they ever want the exact, you just leave it right in the square root. You go ahead and give these a try. Press play when you're ready to see the solution. And there you go. And when we come back, we're going to continue with the converse of the Pythagorean theorem.